So the first thing in terms of meaning, inheritance is all about taking common attributes and common methods, putting them in superclass so that subclasses can reuse them. And this allows us also to make the maintainability much easier, because we have the common code in one place. If it changes, we change it in one place, and other subclasses will inherit the changes. So subclasses, they come and extend superclasses. They extend superclasses by adding their own attributes and their own methods. They can also override superclass methods, which means they can take the superclass method and change its implementation or implement it in a different way. And finally, one note to keep in mind that constructors are not inherited, but from the subclass, you can call the superclass constructor using the super keyword, and you pass the parameters to allow the constructor to initialize the private attributes of the superclass. So it is hopefully all it's clear. We have went through all of this. We've seen it through examples. Now I want to build on top of this and explain this important related concept, which is polymorphism. Polymorphism, it takes inheritance to another level. So I think I want to introduce the concept first through an example, and then go through the concept together to clarify it further. Okay, so I already showed you this inheritance hierarchy last time. So what I have here, I have a cylinder, and the cylinder inherits from circle or extends the circle by adding this attribute height and get height and set height, and also by having this extra method called get volume. The circle extends the shape by adding this attribute get radius and set radius and get radius, and also it has its own implementation of get area. If you recall, the shape, the get area is an abstract method, which means there is no general way of implementing get area. It is implemented in a specific way in each of the subclasses. And because this method is abstract, the whole class becomes abstract, and we can no longer create an instance of this class. I cannot create an instance of this class, but I can use the class as a data type and instantiate the class using one of the subclasses, in this case, either a circle or a cylinder. So you're already familiar with this hierarchy, inheritance hierarchy of cylinder extending the circle and the circle extending the shape. Now the scenario I have at hand is, let's imagine I want to create a list of shapes, or a list that it could contain a circle, a cylinder. Later on, it might contain a rectangle, a triangle, any of the subclasses of the shape. I can put them together in one list. So in here, to be able to do this, what should be the data type of the list? Shape. If I put it, for example, as a cylinder, then it's okay for adding cylinders, but I cannot add a circle to that list because the type is cylinder. So that's why it is recommended when I have hierarchy like this, an inheritance hierarchy, which class should I use as the type for a list or for an array? Is the top superclass. Why is that? Why should I declare my arrays as my list? Yes, so I can put in that list any of the subclasses, and it should be found. Yeah. So that's the first idea. The second idea is that, take a look at this. I created a couple of objects, and I went ahead and added them to the list. And then what this loop is doing is going through every shape in that list. And in this case, it's asking its shape, please tell me what is the class that this object belongs to. And I just want to get the simple class name. For example, if the shape happens to be a circle, what this will return? circle. If this shape happens to be cylinder, these methods will return cylinder. Okay? So that's the first thing. Second thing, I take this shape and call the toString. Yeah? So take a look. So now, let me run it. So I just show you the behave. Yep, yes, please.
It's only the shape dot get class.
Yep.
What would it print without the class?
Yeah, no problem. So it will return the whole name, fully qualified name. It will say, yeah, sorry, just a second. I just want to comment this out. I just want to focus on the loop. So it will say this class inherit, it gives the whole package followed by the class name. But if I am only interested in the class name, I can basically add get simple name. Simple name will give me just the class name, which is in this case circle or cylinder. Yes, please.
Why do we add that toString?
Why did I add that toString? You mean I can remove it? It will also work without it. But what I mean, what is the role of toString? Sorry? The toString returns a string representation of the object. If I have an object and I want to return it as a string, this toString is a very convenient method. It is defined in the superclass, in the object class. Remember last time we discussed this? So all classes in Java, implicitly, by design, they inherit from the object class. Now, that toString, take a look at this. This is the toString. This is the default implementation. This is coming from the object class. This object class, this is built in Java. It's not our code. It's Java code. Let me go back here. Go to string. The way they build it, they just return the class name. Can you see here? Get class.name. And then at, and they return the hash code. They take this name and hash it. Hashing is another algorithm. You might see it later on in other course. It's kind of outside the scope of this course. It's just to transform this string into a hash. A hash, you can think of it as a fingerprint of a string. So you can take a big string and convert it to a hash. And this, in most cases, this is not very useful. If I go to an object and say toString, it returns me the class name at some number. It's not very meaningful. Usually, in most classes, I will go to this toString and override it, which means I provide my own implementation. So let's take a look at the circle. Can you see here the circle? So I went ahead and override the toString. And what I'm returning in here, I'm returning, oh, by the way, this is a circle. And if I wish, I could replace this with, remember, with at this dollar percentage s, and I can say here get what? Get class, yes, dot get simple name. And then I'm returning the color and returning the area. So I'm putting this nicely as a string and returning it. So if someone wants to see the object as a string, they will call the toString. Even if you don't call the toString and you try to say print system.out.println and you put the object in there, the toString will be automatically called. So it's just a string representation of the object. It's up to me what it is my own definition. Maybe I just return this is circle area is 235, whatever it might be. It's up to me what I want to, how I want to return it. But I'll make it a representative. If somebody sees this string, they will have a good idea about what the content of this object is. Okay, now the cylinder, the cylinder, what I can do here, just to show you a more sophisticated way of doing it, I can basically do it in a little bit better way. Maybe I can inherit. Remember, I can inherit. So I can put this one as S, okay? And there is the height. The color, I already have it. The area, I already have it. I will just return the volume. To be consistent, here is the height. And then what I can do here, I can basically do here super toString. What this will do? This will call the toString of the circle. Plus, I will add a couple of more things, which is the height and the volume. Yeah. So this way, I am reusing the implementation of the circle. Here's the implementation of the circle. Let me just make it consistent. Here is the color, and here is the area. Yeah? Are you following? Yeah? And this one makes it really dynamic. If it is depending on the class, it will give me the actual class name. Yeah? So let me just run it, and then I will explain more what's going on. Okay, so you can see here, in the case of a circle, I am getting that the class name is circle, and the color is white, and the area is 28.27. This is the first cylinder that I created up here. The first cylinder here, which was the first cylinder, because I didn't initialize it, it is by default white, the color is red, and this is the area, the height, and the volume. The second cylinder, it's supposed to be blue, yes, blue, and the height is 9, and this is the volume. Is clear the toString, first of all? So what's happening here is that in this shapes list, I have, in this shape lists, I have placed, in the shapes list, I have placed three things, three objects. Okay, in the shape list, I have placed three objects, which is the one circle and two cylinders. Yes? And then this loop, I am processing them in a very general way. I'm going through them and calling the toString. Yeah? I'm calling the toString on them. Now, how this get executed? When this loop is running, how do we know which toString to call? Remember, we have a toString in the circle and we have another toString in the cylinder. Yeah. How do we know which one to call? Shape. So shape is superclass. Yeah. The toString which is in superclass, it will return all the. So we will use the toString in the superclass. Remember, take a look at this. This is an interesting answer. Take a look at the superclass. Do we have in the superclass, do we have a toString? No. We don't even have the toString in the superclass. So, yes, please. So, go by order. So it's going to print out the circle first and then the cylinder? It's not by order. It doesn't decide which method to call by order. But how does it decide which method to call? Based on the object itself, which means? It will call the circle if the list has the circle object. Right? Yes, so basically based on the data type of shape. So if the data type of shape is circle, then of course it will call the toString of circle. If the data type is cylinder, it will call the toString of cylinder. Yeah. So that is basically, you can see here, you see this method, you see this loop here, we have calling the same method Can you see here? We are calling exactly the same method. Which method are we calling? ToString. And we are getting completely different behavior, completely different implementation. Calling the same method on the same object, but getting different implementation. What do we call this feature? Polymorphism. Poly means multiple, and polymorphism means multiple forms, multiple results. That is the idea. So polymorphism, what polymorphism allows me to do? First of all, it allows me to create a list using the generic type, using the top superclass type. And what this feature allows me already to put instances of subclasses in the same list. Not only this, I can process this list in a very generic way, in very general way, by calling the method, by calling a generic method. Of course, this method is defined in the superclass or in one of the superclasses. For example, the ToString is defined in the object class. Remember, all objects are inherited from object class. But at a runtime, when the program is running, the system will decide which implementation to use based on the data type of the object. So when I compile the program, do we know when we compile the program which lucky object will respond to the ToString? We don't know. When we will know this, when the system will know which method to actually call?
When it gets to the...
At a runtime. So we always distinguish between two times. There is the time you compile the program, and there is the time somebody will run the program. Yeah. So for example, in here, when I say add shapes.add, do we know which object will do the add shape, the add? Of course we know, the shapes object will do it. But in here, we don't know exactly which implementation will be used. We will only know at a runtime, and the system will work it out. Based on the type of the shape, if it is a circle, it will call the implementation in the circle. If it is if it is cylinder, it will call the implementation in the cylinder. And this feature is called polymorphism. It's very, very powerful feature. Allows me to do programming in a very general way. And it makes my program much more extendable. Much more extendable. So for example, let me now, just to show you super quickly, I create a new class. I call it rectangle. Rectangle, okay? And this class, how do I make it implement shape, or how do you make it inherit from shape? Extends shape. So I'll go here and just, because I forgot the area of a rectangle, is basically the length times the height, yes? That's the area. That's the area of rectangle, yes? So I will declare first these two variables. So private int length, we'll spell it like this, and yes, okay. So those are two things. Okay, no problem. Yep. Okay, in here I will just super quickly go to source, generates getters and setters, and then I will go ahead and generate a constructor. Source. Okay. two constructors. One is one doesn't take any parameter, and the other one takes the color, and it takes the length, and takes the width. Yes? So for the color, we will pass it to the superclass to initialize the color, and then we will initialize our own attributes, set length, and then the other one is set width. Yep. Are we done?
The area.
Yeah, if we stop here, we will get a complaint because we are extending shape, and shape has an abstract class called getArea. We must implement it because there is no generic implementation of getArea because each shape has its own implementation. So we must implement the getArea. So I can say, come here and say public double, is it double? Okay, getArea. Basically what Mr. Google told me is the length times the width. Yeah? And just to make sure that I am spelling the signature correctly and there is no errors in the signature, and just to remind myself that this is really dictated by the superclass. The superclass is asking me, you must implement this. I'm just reminding myself I did override that method. And there is no mistake. Signature is correct as expected by the superclass. Are we ready now? Can we create a new?
The error is gone.
There's still some error? No error now. Yeah?
Now it's gone from the.
Yes, yes. There's no error now because everything is, the shape is happy, we extended it, and we have implemented the abstract class, the abstract method. Okay. Now I can come to the list. Take a look at this. This general code will not change at all. That's what the power of polymorphism is. The generic stuff will not change. I can come here now. I basically come here and create a new rectangle. And basically I can make it yellow, and the width is 6.7.5, and this is the length, and the width is 5.8, for example. Yep, that's it. And what I do with this rectangle, I can go to the shapes and add it, and here is my rectangle. Yeah. Do I need to do anything to the generic code?
No.
I don't need to do anything to the generic code for storing the actual new shape that I created, and no change to the generic code that comes from that I wrote before. That is the power of polymorphism. I create general code, and if I add more subclasses, no change whatsoever to this general code. That is what the power of polymorphism. So if I run this, everything is okay, except here, what I'm getting here, I'm getting the name of the class plus the hash code. Yeah, this is the default implementation coming from object, because I didn't have my own, and the shape did not have its own. So it is going back to the super class, which is the object, and getting that implementation, which is not very interesting. Let's have our own. Let's put one in here just in case. Yes, we can override it. We can override it here in the shape. So if there is some new shape, they didn't put the toString, their own toString. At least we will have a generic one that is not too bad or better than what we get here from the Java people. This is what Java people gave us. Not very interesting. just has the class name and some hash code. By the way, this is not the memory location of the object at runtime. No, it's just a hash code. To override the toString belonging to the superclass. Okay, now in here, what I will be doing, return string.format. Please try to use as much as possible string.format instead of concatenating using plus. So what I put here percentage %s space, and then I will put here area %.2f. And then how do I get the name of the class? Get class. Remember, get class, it's coming from the object. It's already implemented by Java people. But get simple name. This will give me the class name. And then how do I get the area? Get area, which is, this is very, very interesting. Although this is abstract, I am calling it. Do we know which object will be giving the implementation? Yes, later on. At design time or at compile time, we don't know. We will know later on when we use this against a particular object. Then we will know. And that is what polymorphism is. So this is also called dynamic binding. We don't know which implementation will actually supply the implementation behind this get area. We will know this when? At runtime. Not at compile time, at runtime. That's what polymorphism really means. Okay, so let's try it. So if I run this now, so you can see here, it says the class name is rectangle and the area is 43.5. Now in here, this get area, which actual class gave the implementation of this get area in this scenario? The rectangle. Okay. How did we know? When did we come to know that the rectangle is the lucky class that will give the implementation? We only know at this time, at runtime, when we run our program, when the runtime tries to call the toString, say, oh, which toString I will call? Will I call the one in the in the object, or in the shape, or in the rectangle? Yeah. So it will ask itself. So it will say, shape is what? Is a rectangle. In this case, the last shape in the shapes. The last shape is a rectangle. So it says, okay, let me call the toString of the rectangle. And the rectangle does not have a toString. So it will go up to the parent. Say, do you have a toString? The shape says, oh, yes, I have. So we call that. Yes? Is clear?
So the toString from the shape.
ToString from the shape. But the toString from the shape is very interesting. The toString from the now we have the toString from the shape. But the toString for the shape does not, for example, this get class and get simple class, this will be evaluated on the rectangle. Yeah? So basically, all these methods will be evaluated on the actual shape that we are dealing with inside the loop. Yeah? And the area, definitely, it will come from the rectangle, not from the shape, because the shape does not have any implementation. So that's basically the polymorphism. Polymorphism is nothing but, first of all, the ability to put the ability to put objects from different subtypes into the same list. That's the first ability polymorphism gives us. Then we can do generic code to call this shared method in the same loop. And then we leave it at a runtime. At a runtime, the system will decide which actual implementation will be called based on the data type of the object. So you see here, this object, when I loop through this loop, the toString, the implementation that will be called will be based on the data type of the shape. So at the end of the day, what I have here I am calling the same method, but magically I am getting different implementation and different behavior and different results. That's what polymorphism is. It's a very powerful idea, and it's nothing strange. Like, we see this around us in the whole universe. It's a really powerful idea. We have the same concept, but implemented in a very different way. So, for example, we have in the universe, we have the concept of dawaran, or circle, or rotation. Yeah? So we have, for example, the Earth rotates around itself. This rotation, of course, is very different than rotation around the sun, for example. But the method is the same. We can all understand the concept of rotation. We can see wheels rotate, and the effect of that is movement. We can see, for example, the Earth rotates around itself, and the effect of that is what? The day and night. Rotates around the sun, the effect is the seasons. Yeah? Okay, let's say the blood circulates in the body as a rotation, okay? And then what is the effect? Is it movement? Is nutrition taken to cells, for example? Okay? So the same concept or same action, but done in a totally different way. And the effect of it is totally different. Yeah? Is clear? Yes, please. Do you have a question?
No, I just wanted to give another example.
Yes, yeah, you can give another example.
We already took it, the pet and the talk method.
Yes, very good, yes. Yeah. Yes, we have many examples. Even we have an example in one of the surahs. I forgot which surah, but basically it says, كُلٌّ قَدْ عَلِمَ صَلَاتَهُ وَتَسْبِيحَهُ. So every creature, they know how to basically make their prayer, but different, very different. But the act is the same. That's what polymorphism is. Same method or same kind of action, but done in a very different way. That's what polymorphism is. So conceptually is clear? Okay, so I want to now jump into cover it a little bit in more details with my broken pen. I think I lost something. Anyway. Oh, it's still working. Okay, good. All right, so this is what polymorphism is. I already posted some slides. So polymorphism in Java is achieved using two methods, abstract classes and interfaces. And I'll explain these two methods. First, let us see what polymorphism is. So polymorphism, in a concrete way, in a very practical way, what it really means is the ability to use a superclass type as a method argument, as a return type, or as an array type. What we have seen so far, we use the superclass type as the array type. I will show you the other usage shortly. Okay? And then we use the ability to use variables of the superclass type to call methods on the objects of subtype. It's the conceptual explanation is a bit hard, but the actual implementation of it is quite straightforward. So what it says is that you use the super type as the data type, either for a list or for a parameter or for return type. So let us make this more concrete. So here is an example of using supertype as parameter of a method. Take a look at this. So here I want to calculate the paint. Very interesting. If I want to paint some shape, and I want to calculate how much it will cost me. Yeah. So what I can do, I don't need to have calculate paint for rectangle, calculate paint for circle, calculate paint for cylinder, calculate paint. I can create a generic one. What does it take as a parameter? Shape. Instead of taking as a parameter one of these specific subtypes, it takes the shape. Then all it does it will, let's suppose the price is 5, it will multiply the area times the price and return you the cost. Okay. Now, this get area, we don't know what will be the implementation. Because remember, shape, in our example, get area is abstract, which means it's not even implemented. So how the system will know which get area will be called? At runtime, based on what? The data type of shape. If it is a circle, the get area of the circle will be called. If it is a rectangle, the get area of rectangle will be called. If it is a cylinder, the get area of cylinder will be called. So what you can see here, this polymorphism allows me to create a program that is more generic, function that is more generic. So instead of repeating this logic for a circle separately, for a rectangle separately, I am basically creating one and passing to it a superclass, and then the implementation is very generic. Is clear? So this is an example of using a polymorphism. In this case, in polymorphism, I am passing the superclass as the parameter to this method. That's an example. The other example I already showed you, I used the superclass as the data type of the list, of an array or a list. And then in these elements of the list, I can put instances of any subclass. As long as it is derived from shape, I'll be able to put it in the elements of the array. The third usage of polymorphism, I can use, can you see here? I can use the superclass as the return type. In here think of it as some kind of factory creating for me objects. So I can just ask it, please give me, the shape could be enumeration. Please give me a rectangle, please give me a circle, please give me a circle. Right, this is a mistake here. Please give me triangle. So I can have one method that can return different objects. So to summarize, what polymorphism allows me, it allows me to use the superclass as a data type for a list, as a data type for a parameter, or as a data type for return value. That's what polymorphism, one aspect of polymorphism. Okay. Now, then, when I call a method on this superclass, the system will work out, at a runtime, will work out which object, which implementation will be actually called. And that will be, of course, that will depend on the data type of the object I have at hand. Depending on the data type, the correct implementation will be called. And that's where we have this name, polymorphism, because each call, let's say, as I showed you, I have an array of shapes. I look through them and call the get area, let's say, or toString. Each call gives me different results, and that's what we call polymorphism. And there is something called dynamic binding. So don't let this confuse you. Dynamic binding means the binding between the call and the actual implementation is done dynamically at runtime. There is some in here. What is the opposite of dynamic? When you hear no. Opposite of dynamic is static. Okay, static means it is done at compile time. It's fixed. Dynamic means it is done at runtime. Whenever there is a time, it is dynamic. So, for example, the name, is it static attribute or dynamic? Not in general, in a real life, name, static. It doesn't change with time. What about age? It's dynamic. We hope it is static, but it is dynamic. It changes with time. Yeah. So in here, dynamic binding is, for example, in here, in this area, in these elements of the shape, I might call here get area. I call it on this element 0. Can I know which object will respond and actually do the get area? We don't know. When we will know? At a runtime. When the program is running, then I will know. Yeah, that's what we call dynamic binding. Dynamic binding, which means the binding between the call and the provider of the implementation is done at runtime when the program is running. That is the idea. So that's what polymorphism is. Let me just summarize. So using a polymorphic array, if I declare it using the super type data type, I can place in here, in this first element, I can place a rectangle, second element, a circle, third element, a triangle, no problem. The second example, I have a method that takes the generic superclass type, and I can use one method to handle all scenarios. And the get method, the actual implementation, I will know it at a runtime, and that's what we call dynamic binding. I can also use it for return type. Less interesting, but still keep it in mind. I can have one method to create any object and can return me the super type. And this is another example, of course, of showing polymorphism. I can have an array of pets, for example, and in that array I can have cats and various types of dogs, maybe a bird, whatever it might be, as long as it is deriving from animal or from pet. And then I can look through that array and say talk, and each element of that array will provide a different voice, or will have a different implementation. Yeah. Okay. What is the benefit of doing this? The benefit is I can do programming in general. So for example, that loop I went through to go through the shapes, it does not change. If I add some extra subclasses, as I showed you, I added a rectangle, I can add triangle, I can add other subclasses, nothing will change. The generic code will still function as it is. So it makes it possible to call a methods with different implementation with the same interface. Think of it as some kind of remote control, universal remote control. So maybe we are familiar with this scenario. So each device has its own remote, and it's a nightmare. Like sometimes they are similar, you lose one of them. So it's much better. Sometimes you get a remote, generic, universal remote. You can use it to control any device. Yeah, that's the idea. So and the whole idea, it makes it easier to extend. So in this hierarchy, if I added, like let's say, what is it, like a bird or some other pet, no problem. The generic code to look through and to store these pets in a list will be the same, will not change. Okay, so inshallah next time I will further explain abstract classes that I already explained last time. And there is one more concept, which is an interface. So next time I will explain abstract classes and interfaces.